Advanced Science and Technology on August. It's about security issues of cloud computing and alternative approaches. Generally, it consists of 22 slides. First one is introduction, security, general security concepts in the cloud, and some alternative technical approaches like security access control service, fully homomorphic encryption, trusted computing platform with trusted platform model, and NIM multi-party reputation protocol. After that, I will continue with standardization and legal concerns, and then I concluded. Let's start with introduction. Actually, this paradigm, cloud computing, is a business model in this new economic system. It comes from the wasteful use of IT resources. So there is nothing new about technologies, but combining existing technologies is the backbone of this paradigm. But we also present it in a different ways. So this makes a business model. And also, by using the existing technologies, it enhances the existing gaps and also creates new ones. Like many other non-functional requirements, security has to be considered in the early stages of the architecture in cloud computing too. In this work, we examine some solution approaches, technical solution approaches mostly, and compare it with X800 service categories, which are access control, data integrity, and like that. We will see it detailedly. And underline the importance of non-technical issues as well. Let me continue. Security in the clouds. Recent surveys shows us that there is an easing on security in the cloud. This mainly based on the recent research on technical aspects of the cloud. But is it enough? This study shows that some good points that we need more about these aspects. In the following slides, and it's presented as I said. Let's go. The first one, Security Access Control Service, which is abbreviated to ISACS. The examined approach combines access authorization, security application programming interface, and cloud connection security with the existing architecture of the cloud computing, which you well know as IaaS, SaaS, and PaaS, Platform as a Service, Infrastructure as a Service, and Software as a Service. Oops. Yes, the previous model. First, a certificate needs to be created for the access control. This certificate includes some parameters like start time, end time, host name, user ID, and etc. After that, the user task, requested task from the cloud, triggered the beginning of the second step. Mutual authentication takes place between the user agent and specific application, while the application check if the user agent certificate is expired or not. Third, a list of service resources is created by the cloud application. And for that, for secure communication in this model, SSL is used, Secure Circuits Layer. SSL method also used with virtual private network to get the resources connectivity, which ensures the provider's safety by the resource layer. So mainly, you have resources at the bottom which are virtualized, and you need to use these resources. So you have to establish a secure communication, and this is established by, in this model, SSL by using VPN. And at the top of it, at the beginning stage, use access authorization, a certificate method. Okay. Just continue. Fully homomorphic encryption. Well, encryption is very important for data confidentiality, but cloud, by considering the cloud, it has some problems, like how you process the data, encrypted data, how you understand. So, any file can be encrypted and stored in the cloud, but if one can use the benefits of cloud, like computing power, the cloud service provided has to hold the keys. So this is a problem. You have to trust. But full homomorphic encryption mirrors certain operation done on the ciphertext to the plain text. So in theory, this seems a complete solution for the trust issue. But there are some drawbacks. Let's see them. For example, this example is taken from RAIN, I think, and for example, C1 and C2 are two ciphertexts which are encrypted by plaintext C1 and C2 with the public key. Then multiplication of C1 and C2, plaintext multiplication, has to equal to the decryption key and the multiplication of C1 and C2. So, in theory it works, but two reasons lie behind as drawbacks. One of them is the result of operation on ciphertext is also encryption of the actual result. So, the process, the computer, the cloud part does not know how to process the data. So it's also encrypted. The result is also encrypted. Therefore, the cloud cannot take any action based on the result. The other one is inefficiency because of key sizes and encryption. I don't know, have you ever tried to encrypt, trying to solve an encrypted file, but even 31 bits, trying to reach 31 bits, take my computer, personal computer, and it's a good one, 3 and 4 days, I think, and today files are encrypted with more than 2046 bits. So this is a big issue. Let's see another technical solution, and this is trusted computing platform with trusted platform model. Actually, Shannon Tong proposed trusted computing platform for authenticated boot and encryption. So basically, it's a hardware solution. How? Audit logger is used as an hardware, and in the boot process, audit logger inspects the boot process. So, with the authenticated boot service, monitors the booted operating system to provide drastic all the information necessary for applications. After that, to pursue configuration parameters in a safe way, TPM is the main core of hardware. With TCP suggested by researchers, TPM is a logic-independent hardware, held the private master key. Also, hardware certificates can store in TPM. Therefore, TPM has act as a provide trust root for users. Why? The researchers highlighted traceability improvement as a result of user's personal key is a proof of user's identity. So you cannot deceive, at least the private keys cannot be deceived. Also the other one is authentication problem. So let's continue. So each visitor is known. To use the TCP, the user has the personal identity and secret key. So user is identified as well, at least the shown user. At the end of the booting process, TCP creates a temporary resistant lock by ensuring each chunk of code adds to the lock of the hash of the next chunk that will boot. So it's much more resistant one. Certification of an ONOS is done by TC, and that's important. So certification of an ONOS is done by TC, and then OS can certify the configuration of the application. Also, the TCP shows a better security token by using hardware for random key generation, and another benefit of this approach is TPM can take some computation power from the CPU because it is another hardware. Let's see another one. I think this one is a short paper and currently researching. According to this research, non-repudiation of receipt and or non-repudiation of origin are data transmissions informed in each message. So assume that when sending and receiving messages, you add hiding information in them, and this specific information states ensures non-repudiation. Non-repudiation means you cannot deceive, you cannot deny it comes from you. And also this technique, block chipper, is used, and each block cipher you use different keys, and that's another important point. So let's examine the first part. The owner, from the first, owner sends provider, including the NRO, and then provider sends NRR. So it said I get the receipt. Then after that, owner sends to the user groups, which are the cloud user groups, NRO and NRR. Then after that, user says, okay, I get the message, and I want to use the service, which are cloud. In the cloud part, you want to download a file or you want to share a file. But in this process, you claim you don't get the message. But this can be ensured in step 5 and step 6 by trusted third party. So if a user declares he or she cannot receive the message, or is client part, the trusted third party sends that message instead of him or her. Okay. This the detailed description. And as I said, trusted third party ensures. The fourth one. Standardization and legal concerns. Well, we are approaching to the non-functional properties as well. Field of IT carries some unique challenges, which are working with non-standard materials, and also processes are invisible. So these challenges make this discipline hard to work on some fields. There is not a single standard which covers all aspects of cloud computing. Instead, there are various standards and regulations which can be used, some as guidelines or some as regulations. So let's see what are they. For virtualization, OVP, Open Virtualization Format. What's this format? This format ensures that you deploy your virtual machine platform independently. You can transfer your virtual machine platform to platform easily. Okay. So if you use this standard in the cloud, virtual machine deployment or transferring virtual machines are easy to make. Also, there are some other to ensure security service provisioning, like provisioning like information technology infrastructure library or some standards. Some good security standard declaration 27001 and 2. Also, there are communities which combines with from two parts, cloud part and client parts, like Cloud Security Alliance. So there are discussion forums too about these subjects. Well, regulations. In United States, getting the information disclosure of customers' information is easier than the Europe. So we cannot say it's safe because the regulations in the United States cannot make either the cloud service providers either can be accepted by, as an electronic communication service or a remote computing service provider by the regulations of United States. So just a court order is enough for the US government agencies to get the stored communication and transactional data instead of search warrants. In Europe, we can see it's more solid ground about this subject. But lately I listened one of the Commission party leaders in Europe declaration about security, and he said that they are way behind the United States. I don't get the point because the regulations clearly states that European is for security and data confidentiality way front of the United States, and these are the causes. For example, like there are some certain exceptions which can fall under these categories. You can get the data, and furthermore, in this directive, a security breach has to be reported to the necessary legal place. So if a breach happens in the cloud, they cannot deny from the legal authorities by the help of this directive. Also, there is an article states that restriction for transfer of personal data outside the European Community. Let's continue. Conclusion. Well, let's see X800 categories. It's authentication, access control, data confidentiality, data integrity, and non-repudiation. Let's examine the technical approaches. Security access control service satisfies the authentication and access control, but not the others. Fully homomorphic encryption satisfies the data confidentiality and not others. Trusted computing platform with trusted platform module satisfies authentication, data confidentiality, data integrity, and this new protocol is currently under research, satisfies non-repudiation. So you see none of them satisfies the full category. And also, cloud computing services may be misjudged or may live outside of regulations because of the combining different technologies like as say data processors or data satisfiers, the cloud and data controls data processors. The cloud is also a matter of global business, therefore constructing a win-win system which covers all various aspects of cloud computing is crucial. So we cannot think this as only a technical problem, only a technical approach. This affects business. So we have to think different and cover other aspects as well. Revision of existing laws is a must, but this should not be done without the contribution of the industry associations. I know in Europe there's a good one with including Cisco and other main companies. They have force on the governments. Also, supervision of new computer translation standards and the existing ones is critical for the future of the cloud. Therefore, enforcement bodies needed in a global scale reinforced by task forces all around the world. Here are the references if you are interested about the topics. And
sounds good.
that's all.
Thanks for the nice presentation, Mr. Arda. Any questions? So you will be given points for asking questions. Don't forget that. No question, Fatma Nurhan? Back row. So I have one question. You can go back 2-3 slides ago. There was a table, right? You said none of them
Yes.
satisfies that. So you have like 5 criteria there, right?
Mm-hmm.
Authentication, access control. My question is where do these criteria come from? Are they really do they include all the security issues, or like those 5 criteria?
No.
Like why aren't there 6? Like why just 5 criteria?
X800 is a commonly known general security categories, but under these categories there are many detailed
Subcategories.
Yeah, subcategories. And also, if one covers all the aspects, current technology not permits it, like fully homomorphic encryption. It is theory good for a solution, but in practical life, it's impossible to implement that.
Okay, and which one is that?
Fully homomorphic encryption, and it's just one data confidentiality issue.
Okay, so when is your conference?
It's 12 August, between 12 and 15 August. I don't know which day.
Which country? Where are you going?
Antalya.
Antalya, Turkey. Sounds good. I think, yeah.
Thank you.
Nice presentation. So let's go. Applause for our friend.